Okay, folks, I think we are back. Let me try once again sharing my screen. And once again, I'm going to live dangerously and show the whole thing. So, um, when we were talking about ideas for talks and projects and things like that, um, one of the things that I just happened to mention, and somebody said, "Well, this seems like it'd be an interesting, little challenge type of project to do." And I'm going to talk to you about something called AIS point prediction. So here's the general idea. And if I was better at drawing graphics, I could have drawn you some graphics. So I'm going to try going out here to OpenCPN to see what kind of things we got going out here. What I really need, and I probably don't have. Well, actually, I probably do have. But um, you see these vessels out here. This vessel right here, the Janus, we know is a sailboat. It looks like it's about to come in Ponce Inlet. The Sea King, I don't know anything about the Sea King. It's also a type B. That's too bad, but that's okay. On AIS messages, vessels that are by Code of Federal Regulations required to transmit Class A type of vessels. So the really big ones have a lot of passengers, have a certain tonnage or horsepower. They're Class A. And a Class A is going to be telling me all the information that's down here. They'll be telling me a speed, course, heading, and turn rate. They'll also be communicating relatively frequently. Class B vessels, the smaller ones, um, aren't required to transmit. And in fact, in a Class B position report, there's no way to even tell me about a turn rate. So the reason I'm telling you that is so that I can tell you this. My question is, and here's an example of the Louisiana, which was just offshore pretty recently, a tanker offshore Daytona. So if I know a ship's latitude, longitude, speed over ground, course over ground, and turn rate, can I predict where they will be the next time they give me a position report? And in some ways, this sounds like a trivial exercise. I fooled around a little bit with it, not a lot. It's a really interesting exercise. Um, and the idea came to me some time ago. The idea being, I'm at a particular place, and suppose a bad guy spoofs their AIS latitude, longitude of a vessel, and they try to, let's say, knock Louisiana off the air, and now they spoof being Louisiana. Well, their suppose their next position report puts me 5 miles away. Well, there's no way that I can move 5 miles in a minute. So my AIS receiver could maybe flash red to say, we just got something that just doesn't seem right. Um, Now, the other thing, by the way, that this AIS message will tell us, this position message, this and other things, is you'll notice that this is also giving me the destination and the ETA when I plan on getting there. So this vessel, which I saw the other day, probably about 4 or 5 days ago, is expected tomorrow morning at 7 in the morning UTC to be in Texas. So it must have, it must have been several days ago. Anyway, so where I'm going with this is this. Again, an AIS type 1, 2, or 3 message is a Class A position report. And the information that matters to me is it's going to give me a latitude. For those of you that are not familiar with the relationship between latitude, longitude, and distance, it is vaguely as follows. 1 degree of latitude is 60 nautical miles. 1 minute of latitude is 1 nautical mile. Longitude is about 1 degree of longitude is about 60 nautical miles at the equator, which is 0 degrees latitude, of course. But for any other latitude, a degree of longitude, the linear distance is going to be some function of the latitude. And think about a globe. And of course, as you get closer and closer to the North Pole, 1 degree of longitude gets to be almost nothing, whereas 1 degree of longitude at the equator is 60 nautical miles. Anyway, I mentioned that later on. Um, then we're going to have the course in degrees, 0 degrees being true north. And so an actual course will be somewhere between 0 and 359. The speed in knots. A knot, of course, is a nautical mile per hour, which translates to about 1.15 miles per hour. I'm going to have a rate of turn, which is generally expressed in the number of degrees per minute, left or right. And the time between transmission is going to be a function of what is your speed and what is your rate of turn. And it turns out there's a standard for this. And if only the standard matched the reality, life would be a good thing. But here is actually an example and talks about some of the additional issues related to the problem. So I only care about the Class A transponder types, although I'm showing you Class Bs as well. So technically speaking, if you're a Class A vessel you're at anchor, you just need to transmit every 3 minutes. Now, you may be saying, but I'm at anchor, I'm not moving. Well, again, AIS Class A devices, you might be talking about a vessel that is several hundred meters in length. If it's anchored or moored, the position of the bridge might be actually composing a circle that if that ship were to swing around its anchor in a 360-degree circle, you might be talking about a radius of many hundreds of meters. Well, a nautical mile is about 2,000 yards. So I might, like I said, I might have a pretty big swing radius. In any case, if I'm sailing, not sailing obviously, but underway, between 0 and 14 knots, I'm supposed to be transmitting every 10 seconds. If I am sailing at a speed of 0 to 14 knots and changing course, I need to be transmitting every 3.33 seconds. So that's how you read the chart in terms of transmission rate. What I did is I then translated this and said, well, what's the maximum distance I can travel in that amount of time? Well, if I'm going 14 knots and I'm transmitting every 10 seconds, I'm only going to be traveling 77 yards. That's not very far. And you can sort of see as I progressed here, what I was trying to give was an idea of exactly how far might I be going between transmissions. Now, I mentioned I wish the reality were, match the standard. Sometimes we will see vessels going by that are Class A vessels, and they're pretty big Class A vessels, and like the Louisiana. Um, the Louisiana was going at 15 knots. Well, at 15 knots, even in a straight line, they should be transmitting every 6 seconds. But we had like a minute. That slide that I showed. So in any case, so the distance, or rather the rate between transmissions, is something else we need to take into account. So then I said, well, look, um, I've got a ship here that's supposed to be a ship, and it's at some latitude and longitude, which I'm calling lat 0 and long 0. I know my course over ground. I know my rate of turn. And so the question is, all right, well, I've got a triangle in here. I've got some angle theta. Now, this may or may not be the right approach to go, by the way, but I've got some angle theta. And so at some t time later on, I've got my new latitude and longitude, lat 1 and long 1. And so I will observe that I can figure out the radius of this circle because it's going to be related to the speed over ground and the rate of turn. I can figure out the distance that I've traveled, that circular distance, that the arc, if you will. That's going to be somehow related to the velocity times the time between the transmissions, the actual time. And then I've got this delta x and delta y. Well, delta x is going to be a function of the angle of the circle, the speed over ground, and the time, which as will my delta y. But then my actual change in latitude and longitude has got to be a function of the course plus theta, meaning that if I was just going due north or do anything, it'd be easy. But as we start to change off of 0 degrees, we start to see, some complications. Because again, a degree of latitude is the same everywhere in terms of linear length, but the linear length of a degree of longitude is not going to be the same. So, like I said, we have, that issue to deal with. Um, so again, my targets that I'm going for is, if there's no rotation of the ship and the ship is moving in a straight line, well, that's almost easy to do. Um, if the rate of turn is not 0, my ship is turning. Um, and so then the other thing I was thinking of is not only how well can I predict my next point, but we just had a tropical storm down here last week, went up the East Coast. And so we always look at the National Hurricane Center, and they give us this cone of certainty for, so that if my next point is in the box, do I claim victory? And am I looking for, well, a really small box, or how big will I let my box be? If I'm going in a straight line, they really are sort of boxes. If my rate of turn isn't 0, then the boxes actually become a cone. Am I anywhere in the right range at all? Um, so, like I said, in terms of a problem, I was just thinking that this sounds like an interesting problem to tinker with. And um, and there's all sorts of places to look at historical information. What you need to work on, though, if you get historical information, and I could even provide you some, is you need type 1, type 2, or type 3 position reports from the same vessel. And and the type 1 again, because you need rate of turn. Now, I mentioned something about the length of a degree of latitude and longitude. So again, the length of a degree of latitude in meters, there's a formula that I know is used at a number of the government sites. It was actually easy to find the formula because they have these pages where they have like a JavaScript, and you can put in you know what your latitude is. It will tell you the length of a degree of latitude in meters. Well, of course, if you right click and look at the page source, you can see their formula. But it's been used a lot, and I've seen it documented in a few places. In any case, the length of a degree of longitude, again, you will also notice, is a function of the latitude. The length of a degree of latitude and longitude, here's a table that I produced largely from those formulas. And you'll notice that a degree of latitude, in terms of nautical miles, it almost doesn't matter where you are. It's about 60 miles, 60 nautical miles to a degree. If you look at a degree of longitude, the number of nautical miles, again, at the equator, it's about 60. And then as you go towards the poles, it increasingly gets smaller and smaller, and then rapidly gets smaller once you get above about 45 degrees, um, either north or south, and that actually makes sense until, of course, you get to the pole, and then the degree of longitude is 0 nautical miles. Um, and again, I've given you some websites where they have more information about this. And that more or less was the challenge. And as I said, I think it's sort of an interesting problem. Um, and for a few people, I don't know where we sort of go from there. Like I said, I talked to Reed out about this, and I think he talked to a couple of other people. Interesting problem. I think what we're looking for is maybe to have some intermediate solutions at some point in the next year. Maybe revisit this at Have to See 3.0 next year. And anyway, so that's where I am. So Questions? Comments? Let me go back up here. No, I'm no longer at Hack the Sea Village. So I'll sit here for a couple of minutes while we go into Q&A.